Welcome to today's lesson. In this tutorial, we will add and subtract radical expressions. So today we are adding and subtracting radical expressions, but before we do that, let's remind ourselves about the parts of a radical. Our radicals have this symbol right here called our radical or our radical sign. There's a little number tucked up in here, and that is called our index or our root. If you don't see a little number here, it's implied that it's a 2 for a square root. Then we have a number or a variable or both underneath the radical sign, and that is called our radicand. Those are our important vocab words. So today for adding and subtracting radicals, we're going to follow these two steps. Step 1, let's simplify any radicals that are not in simplest form already. And then once that has happened, we will combine any radicals that have the same index and the same radicand. That means that this little number has to be the same and this big number has to be the same. So let's look at example number 1. In this first term, I have cube roots of 2. In my second term, I also have cube roots of 2. Since my little index is the same and my radicand is the same, I can combine these radicals together. I'm going to take the coefficient of 3 and the coefficient of 1 and add them together because that's what the plus sign means. 3 plus 1 is 4, and cube roots of 2 plus cube roots of 2 make more cube roots of 2. Nothing changes with the index, nothing changes with the radicand, and that's it. Simplified. Let's look at number 2. Now I'm dealing with square roots. This first term has a square root of 3, and this second term has a square root of 12. So the radicand is not the same. Not yet. I dealt with square root of 12 last class. Do you remember? Let's come off to the side and deal with this square root of 12. Let's simplify square root of 12. Now, there are many numbers that go into 12, that divide into 12, but the most important, if I'm dealing with square roots, is a 4. I'm going to change 12 to 4 times 3. So now I have the square root of 4 times 3. I'm going to separate them into square root of 4 and square root of 3 individually, because the square root of 4 is a perfect square and a 2 gets to escape. The square root of 3 will just stay the square root of 3. So what I've done is I've changed my square root of 12, I've rewritten it to look like 2 square roots of 3. Now let's go back into our problem. The first term was 2 square roots of 3, and that's just going to stay 2 square roots of 3. And then I have my plus sign. My second term, square root of 12, I rewrote to be 2 square roots of 3 as well. So now I've got another 2 square roots of 3. Can I add my terms together now? Yes, they're both square roots and they both have the same radicand. So I'm going to take their coefficients 2 and add them together to make 4. And then the square root of 3 is just in my answer. Nothing changes the index and nothing changes the radicand, not when I'm adding and subtracting. Great. Let's look at example 3. This time I am subtracting, but that does not really change that much. I have square roots of 6 and square roots of 6 in my other term, so I can subtract these right now because they have the same index and the same radicand. I just need to take their coefficients of 10 and negative 6 and combine them together. 10 minus 6 is 4, and the square root of 6 is just in my answer. That's it. We just have one more example here, example 4. Now I have 3 terms. This first term I have a cube root of 5, the second term has a cube root of 40, and the third term has a square root of 5. Well, let's talk about this cube root of 40 because that sounded familiar. I'm going to take this term right here and I'm going to work with this term. Let's go right here. So the 2 has already escaped, and then the cube root of 40, I'm talking about cubes this time, so 4 is not going to be helpful because 4 is a perfect square. I want a perfect cube that divides evenly into 40. And if you're not sure what that is, maybe use the other part of the problem as a hint. I do see a cube root of 5. Maybe 5 goes into 40 a certain number of times, and it does. 8 times 5 is very helpful when I'm dealing with a cube root. So cube root of 8 is good. I'm going to leave this 2 out here. And then I'm going to separate the cube root of 8 and the cube root of 5 individually. this 2 that's still out here, and now another number gets to join it. The cube root of 8 becomes a 2, and I'm going to multiply those together. The cube root of 5 will just stay the cube root of 5. So this becomes 4 cube roots of 5. So again, all we did was we changed this middle term. We rewrote it to become 4 cube roots of 5. Now let's go back to our original problem. We'll take this term. I've got 16 cube roots of 5, and then a minus sign. And then this second term that I rewrote as 4 cube roots of 5. And don't forget we do have this other term that we didn't do anything with. I'll bring that down, plus square root of 5. So, can I combine all of these together? No. I can only combine cube roots of 5 with more cube roots of 5. The square root of 5, I can't do anything with that because I don't see any other square roots. So this will just stay in my answer. But 16 take away 4, I can combine those. 16 minus 4 is 12. 12 cube roots of 5. And again, this positive square root of 5, I can't really do anything with that, so I'm just going to leave it in my answer and be finished like that. Great. Thanks for watching this tutorial. We will add and subtract radicals in class. Bye-bye.